When people flew the Concorde, they didn't notice how fast they were flying. They didn't know that they were flying 2 times the speed of sound other than this little marker that sat in front of the seats and told them. But what they did notice is how much time they spent on the ground and not on an airplane. When you push that speed up to 5 times the speed of sound, that makes effectively the world regional.
Commercial airplanes today fly at about 600 to 650 miles per hour, which is around 8/10 the speed of sound. Since the retirement of the Concorde in 2003, fuel efficiency and cost effectiveness have been prioritized over speed. But what if the key to the future of travel and trade is 3,000 miles per hour hypersonic flight?
When you bring places closer together, you remove barriers to the movement of goods and people, you tend to grow trade. And that drives larger and larger social and economic growth at a global scale, the likes of which we haven't seen in a very long time.
My guest today is AJ Piplica, a founder and the CEO of Hermeus, where he leads a team focused on accelerating the global human transportation network through the development of hypersonic aircraft. Then later, we'll visit the Hermeus headquarters and explore their engineering, manufacturing, and test facility. We'll preview their first remote piloted hypersonic aircraft, Quarter Horse, and explore their innovative hypersonic ram burner, the Chimera engine. Stay tuned as we uncover a range of topics, from the history and challenges of hypersonic flight to its groundbreaking innovations in the aerospace industry, its impact on the global economy, and its potential to bring the world closer together. The only way to solve our biggest problems is to have the audacity to try. Welcome to In the Arena with Evan Baer.
AJ, I'm really excited to be in this conversation with you because I want to learn about aircrafts and how we travel. The story of aviation of the last 100 years in the West is a pretty discouraging one. We're worse at innovation, we take much longer, the cost has skyrocketed. There's some good news, and that is this new wave of entrepreneurs who are building companies like Hermeus, your business. What is Hermeus?
So at Hermeus, our long-term vision is to radically accelerate air travel with Mach-5 aircraft, to accelerate the development and push beyond the bounds of the frontier that's been set, specifically in speed. And along the way, radically accelerate air power with autonomous high-speed aircraft that support the Department of Defense, and then applying that to particular problem sets in defense and commercial.
Tell me the story of you and your co-founders deciding to do this thing that, from the outside, this seemed a little crazy.
We had worked together for about 3 years in the hypersonics world, mostly around the Department of Defense. So we had a very good feel for what was going on, where the core problem sets were, where money was being spent, and more importantly, where money wasn't being spent yet. Like, what's the next thing? The core thing that drove us to leave our relatively good paying jobs and start Hermeus when we did was, as you lay out the technology roadmap, like all of the things that you have to do to build a Mach-5 passenger aircraft and fly people across the Atlantic Ocean in 90 minutes, along the way, you're gonna have to build some things that are going to be useful in a national security perspective. And that kind of really drove the roadmap. So we'd seen how much money was being spent in hypersonic weapons. We'd seen some of the challenges around those. And we kind of had a theory that, yes, we spent a lot of money on hypersonic weapons. We're going to spend a lot of money on high-speed aircraft. On that front, there was also kind of a responsibility that we felt around that because nobody was even looking at this. Everybody was squarely focused on hypersonic weapons and slow airplanes. And then it's like this Kansas City shuffle. If everyone's looking that way, then we go that way. Not very intuitive, some would argue, maybe too risky, but from our perspective, we saw a gap that if we didn't fill it, some other country around the world was going to. So our particular skill sets as 4 engineers coming up through the commercial space world, having worked together in these kinds of problems, it's a really unique set of people that didn't exist anywhere. That put us in a really unique spot where it's if not us, then who?
I want to talk about the kind of innovation you're having to pursue. The ability to travel at these speeds was kind of already achieved. And I wonder if, in some sense, you're not actually needing to innovate on the engine itself, but more innovate around the business process, the systems engineering that you're a part of. By way of answering that question, remind us of the story of the Concorde.
Sure.
And in what sense you're trying to revive or restore that legacy.
Sure. So I'll start with the Concorde. The Concorde as a program, the reason it happened, the reason it existed, it was the Apollo program of Britain and France. That is the technical achievement that they pursued with a large portion of the research and development funding that they had available to them at the time. There are a ton of analogs between what happened in the Concorde program and why it doesn't exist today, and the lunar program that we did in the United States. I mean, we haven't been back to the moon with people since that program either. They're very, very similar. They were national priorities that pursued technology that was ahead of their time, that didn't have a kind of commercial requirement for sustainability, either in an economic sense or an environmental sense or otherwise. It was really about nation states pushing the bounds and leading in particular technology areas. We haven't been back to the moon because we don't have rockets big enough yet. We're getting there, getting very close. But the reason that we did it in the first place is because it was a national priority. We made it a battlefield of the Cold War. And for Britain and France, that was part of what Concorde was. They were competing against Russia, who was also developing a supersonic transport at the time. They were massively successful, honestly. An engine that can operate relatively efficiently at low speed and supersonic speeds, high temperature environments for extended periods of time, keeping a passenger cabin cooled, all of the unique things, and of course, feitting into existing airport infrastructure. Not an easy thing to do at all.
And it flew for a while.
It flew for almost 30 years.
And I think it was ballpark is around maybe $12,000 a ticket, and it would travel roughly twice the speed of a traditional commercial aircraft. Right. And what happened?
It died of old age. So Concorde flew for about 30 years, and Airbus, which was the company that was basically built out of this collaboration between Britain and France, stopped supporting spare parts about, 15, 20 years into the program. So it was going to end anyway. 30 years is on par with the normal life of an aircraft even today.
Does the legacy of the Concorde haunt you of what you're building at Hermeus? Do you fear that 20 years into your trajectory, history repeats itself?
No. A couple of reasons. It's clear that the technology that we have today, from a materials perspective, from an engines perspective, from a engineering design perspective, gives you significantly more margin than the designers of the Concorde had to work with. Concorde originally had about 300 orders, and I think they were well into their final design phase or even into their certification program when a law came into effect that said you cannot fly commercial more than Mach-5, so supersonic, over land in the United States or in Europe. And after that happened, the order book dropped from 300 to 16, something like that. But I think from the company's perspective, the approach that we're taking is really starting with the military applications of high-speed aircraft, specifically autonomous high-speed aircraft, to get those iterative learnings and reps that we need so that by the time we go to certify and bring to market a commercial passenger aircraft, it is a fourth, fifth generation system. As you build a business around the defense applications, that's going to be a large and highly valuable business in and of itself. It takes a very, very tight-knit group of people, highly committed to moving fast, delivering on a set of de-risking in a fixed period of time. But the trick here is it's not just software, it's not just bits, it's atoms.
The back half of the phrase that you mentioned of moving fast, for a while at Facebook, was move fast and break things. Dealing with hard tech, even thinking about if you ever had passengers on this airplane. I think in a plane crash with the Concorde, 100 plus people died. I was looking back at this and thinking about how major triumphs of innovation often required society to take on great risks, including a loss of life. So how do you think about that for what you're building now? Move fast, are you willing to break some things, but just not loss of life level breaking of things?
Yeah, so in the factory in Atlanta, we have a flag that was flown over the US Capitol and is dedicated to fallen test pilots. If you look back in the history of aviation, all of aviation for a very, very long time was people taking risks with their own lives to push the boundaries and the frontiers of what we knew about flying. And a lot of them gave their lives in that pursuit of knowledge. So it's something that, even though we're building autonomous aircraft today that don't have people on board, we're not asking people to take those kinds of risks. But in the souls of everybody at the company, you can never forget what it took to build up the shoulders of the giants that we're standing on. We're not putting a person on an airplane for a very long time. And that's something that we can do today a lot better than we were able to do back in the 40s and 50s. So that allows us to take a lot more risk from a technical perspective. So we're very, very open to taking technical risk. However, there's a fundamental difference between that type of risk and safety. Safety is not something that we were willing to compromise. Safety over progress, progress over process. You really have to build a culture around where every single individual understands and takes on their own shoulders the responsibility for their own safety and the safety of those around them.
Talk a little bit about innovation at the level of the business model. You are a venture-backed startup. You guys have all sorts of challenges. You got to get really expensive engineers. You're manufacturing airplanes. You're signing long lead time contracts with the government. The things you're building can kill people. I mean, I can't think of really a single way that this is in common with a standard venture-backed startup. So talk about the business model and just bringing this to life out of nothing.
Yeah, it takes a special entrepreneur to learn to like the taste of glass to go and execute on something like this. But it also takes a massive upside if successful. And I'm not just talking about financial upside. If that was the primary motivation here, myself and my co-founders would be doing something else. There are many better ways to make a lot of money than start an airplane company. There's an old adage of like, how do you become a millionaire in like airplanes, rockets, hard tech, whatever it was, you start out a billionaire. So unfortunately, don't have that to start with, so have to do it the hard way. And that hard way is really like go after the like single most critical risk in the business, which was the engine. So we built a small prototype engine where we showed that we could take an off-the-shelf turbojet, push it up to SR-71 speeds, about Mach 3.2, build a ramjet, put it on the back, show that it operated lower than that and up to about Mach 4, and do that we ended up doing like 9 months with about $1.5 million. The real challenge is how you put it all together into a sufficiently efficient system to fly the mission. And that's more than just the engine. It's the integration of the engine, the aircraft, the avionics, everything all together. Because like the faster you fly in the atmosphere, the more tightly coupled everything about the airplane becomes. It's no longer an engine that sits underneath the wing of an aircraft that could be designed almost independent of the aircraft. It's now a flying engine with stubby little wings on the side that you really have to design together. And development program, you start gathering data, buying down all the uncertainties that exist as you start ground testing, flight testing.
Let's take a break from our conversation to go visit the Hermeus headquarters in Atlanta, Georgia, to get up close and personal with their latest breakthrough aircraft, the Quarter Horse.
There are very few things in the world where if you build it, they will come. But I think everyone can agree that flying on a slow plane sucks. Quarter Horse is a series of single-engine vehicles. The first vehicle is our Mark 1. Mark 1 is really focused around takeoff and landing of something with short, stubby wings as a remotely piloted vehicle.
Quarter Horse is Hermeus's first aircraft in a 3-plane series. Walk, crawl, then run. With a cadence of 1 plane a year, they're aiming to succeed in Quarter Horse's ability for remote takeoff.
So this is our flight deck. As I mentioned, that this is a remotely piloted vehicle. So we don't have a pilot station on board, so the pilot stations are in here. It's a pretty simple system. Mark 1 is pretty simple. There aren't a lot of bells and whistles on it, which is how we moved so fast. It takes one person. So that's something that's been really important to us. Now, it takes a team to understand the entire vehicle in case something goes wrong, because there's always unknowns.
The remote takeoff factor is one component of the Quarter Horse program. Moving fast to learn and innovate on this technology is key to unlocking hypersonic air travel. Hermeus's goal is to make a Mark 1 test flight later this year.
All right, good morning, everybody. We'll take a quick look at kind of where we are on milestones and dates. All right, we'll hit it.
Hermeus has a lot to do before meeting their flight test deadline. Previously, they've succeeded in showcasing their Chimera engine. This engine will enable Hermeus to achieve hypersonic commercial flight.
The Chimera engine is really the heart of the aircraft, and that's the specific unlock that allows this company to exist in the first place. Where our engine is a little weird is we actually have to create a custom solution that allows us to operate as a turbojet, as a ramjet, but also in that middle ground where we have that turbojet plus our pre-cooler. And having the tech to actually operate in these 3 regimes is certainly like a demanding technical challenge.
The Chimera engine is a blend of an off-the-shelf commercial jet engine combined with a ramjet engine. Ramjets are a key component of hypersonic flight.
You have your commercial turbojet, which is taking that air in, compressing it, injecting fuel in, igniting it, and generating thrust. And then we have ramjets, which don't have those same compressor sections. It's actually using how fast you're already moving to compress that air in before you inject your fuel in and ignite it. But currently we don't have ramjets that are capable of taking off and landing from a runway. We actually have to speed it up before the ramjet can actually even start.
Hermeus has demonstrated their ability to activate ramjet mode through the success of the Chimera engine. This makes them one step closer to commercializing hypersonic flight. Hermeus is also in the process of parallel developing their future aircrafts. It's important that they continue to learn the successes of each aircraft as they progress along their development timeline.
Success for Mark 1 is remotely piloted takeoff and landing successfully, proving that we can design and build an aircraft that actually gets in the air and actually performs the way that we expect. We still have to prove that. The next one, Mark 2, bigger engine, a lot more capability, and really pushing it into the high supersonic conditions. And then finally, Mark 3, where we're actually breaking the airspeed record.
We're not like going out and building the Mach-5 aircraft right out the gate. Going through the different aircrafts within the quarter horse program, Mark 0, Mark 1, Mark 2, Mark 3, is how we get there and we actually figure out, oh, hey, we actually have a problem here. We need to change something early on. And it allows us to change it when the stakes are a lot lower before the stakes become really, really high on like a very high performance Mark 3 vehicle, because we have a lot of the chess pieces where they need to be before we have to execute on the hard problems.
The amount of learning that you get then compounds over time. So yes, we got a lot of learning by doing this first build, but like when you stack 1, 2, 3 of these on top of each other, and by the time we get to Mark 3, that will be 3 aircraft builds, 4 total system builds. There aren't a lot of places in the industry that you can go do something at that pace of 1 aircraft a year.
We have a lot of really excited engineers who are super jazzed about the technical product, but the company behind that too, the team behind that as well, that's what I really see as the potential that the quarter horse program has built here at Hermeus.
Turns out making hypersonic aircraft is hard. I tell the team all the time, we're not an airplane company yet because we don't have an airplane in the air. And so I think it's really, really exciting to now take the next steps, do some integrated checkouts, start going through taxi testing, and then finally get into flight. And it's gonna be a pretty big milestone for the company, and we're definitely gonna probably have a good time after that, so.
Let's head back to the studio where we'll dive deeper into the future of hypersonic flight's impact across America and the world.
What is at stake if another country develops this technology first?
So I think from a commercial perspective, whoever gets there first tends to get to write the rules. And there are no rules in the FAA today around airplanes that are made out of titanium and have ramjets and can connect countries this fast. From a military perspective, you can kind of see some of the implications of high-speed systems development that's happening in other countries, China, Russia, which from a weapons perspective, hypersonic missiles, I think a lot of people would argue the US is behind in these. The kind of key thing that reusability, like an aircraft, high-speed aircraft brings to the game here is the cost point on some of these kinds of systems drops substantially, much in the same way that like bringing reusability to rockets has done for space launch.
If China announces and they're doing demos of these, what happens if they have days, weeks, months of beating us to the market?
Yeah, I think it just adds yet another kind of asymmetry on their side of the table for objectives that they may have, that they may want to accomplish, and makes our job, which is from a national security perspective to deter conflict at generally a global scale, it makes that job a lot harder for us.
When I imagine the development of sonic air travel as a national priority of China, with trillions of dollars, with 10x the number of engineers, with the possibility of zero regulation, no OSHA representative is showing up and asking about wheelchair accessibility for the plant, right? All the elements of the sclerosis of the US government and arguably of our military-industrial aerospace complex, they have none of that stuff. What about the Chinese approach could enable this innovation more effectively or more quickly in China?
I think it's focus. Focus is a thing that you can get in an autocratic regime where you have like significant top-down control. You can drive focus and advancement in core areas like relatively quickly. An example of this is like if you look back over the past kind of 5-10 years, how much hypersonic flight testing has been occurring in China versus what's been occurring here in the United States. It's about an order of magnitude more.
What is the case to be made that companies in the United States, in this regulatory corporate ecosystem, will win the race to hypersonic flight?
Capitalism. That is something, a superpower, an asymmetric advantage that we have in this country. You typically don't see the construct of the entrepreneur leading development of something with just a maniacal, will not die, will not lose attitude in authoritarian regimes. We can argue about various economic systems all day long and what AI might do to that in the future, but I firmly believe that that is a fundamental enabler, an asymmetric advantage that we have in this country that drives not just the founders of a company, but all of the employees along the way. Not only are you supporting national security and the advancement of humanity's knowledge base in aerospace and aviation with the chance to connect the world faster and unlock massive social and economic growth. So like big outputs and impact at the end of the day. You have a stake in that as well. And it's like, it's the American dream, right? Like go pour your blood, sweat, and tears into a thing that creates massive value and rise above your station. That doesn't happen outside of, I think, Western values.
Tell me a little bit about how you approach your competition. They've got 1,000 times more funding, thousands of times more people. Do you worry or do you find that some of the rules that shape how you have to operate are shaped by regulatory capture?
Oh, I'm sure they are, but I kind of don't care. I think from our perspective, like our job is to deliver a product that is 10x better than the competition. And I think this kind of goes for just about every startup. You have to be shooting to deliver something that is so compelling that it overcomes really any of those entrenched barriers. Because most of those things, there are plenty of ways to get around them. What you need is really the will of a small set of people in your customer set, specifically like within the Department of Defense or on Capitol Hill, to see what you're doing, understand how much better it is than what is available today or what will be available even tomorrow, and say this must happen. And you need that will on the inside to kind of cut through all the bureaucracy and red tape. Back to the early days of SpaceX and commercial orbital transportation system contracts or services contract that they won with NASA. It was like their first big government contract. That wasn't like a mainstream, like major program within NASA. That was basically a set of insurgents who saw the same kinds of things that Elon saw and his team saw, where innovation was really required. And they were able to work within the physics of the system. And I mean like the constraints of NASA and kind of how Capitol Hill worked to get them a shot. And on the company side, that's all you can ask for. You can't ask for any more than that. And then it's really on your shoulders to knock it out of the park when you get that shot. And you usually only get one. It just requires this like maniacal will to just work and work and work and work until you get that shot. And we've seen this in defense. Anduril and General Atomics won a major autonomous aircraft contract with the Air Force that the big primes, Boeing, Lockheed, and Northrop, lost. And that was kind of at least for me, from my perspective, kind of the inflection point for defense technology, much in the same way as that NASA COTS contract was in space launch. And here we are 20 years after that, and what do we have? Complete domination of the world's space launch and satellite capabilities back in the United States again.
Let's talk about commercial aviation. What does a world of ubiquitous, reasonably priced sonic air travel look like?
You will see as much travel going across the Atlantic Ocean as you see up and down the East Coast of the United States today. So whether that's daily business travel, I mean, I live in Atlanta. I spend a lot of time in Washington, D.C., a little bit in New York, and some down in Florida. Those flights are typically about 90 minutes. If you expand the footprint of that like pace of travel, where can you go in an hour and a half? You can now cross the Atlantic Ocean with that. Imagine the amount of trade and commerce. Britain and France will be as close to New York and Washington, D.C. as London and Paris are today by train, 90 minutes. you're like making this step change in activation energy for taking a trip. And it creates time, and time drives trade. And when you apply this at like a global scale, not just across the Atlantic, but across the Pacific, North and South, when you remove barriers to time and trade, you'll see growth in trade across all these, these cities that are connected, which we haven't seen in a very, very long time. But if you like look back in history, there are multiple examples of increasing the speed of transportation networks, driving multiple single-digit points of GDP growth in the affected regions. A couple points of percentage points of GDP growth may sound small, but like when annual GDP growth at the global stage is 2%, 3%, if you're adding 2% or 3% to it, that's trillions of dollars.
But in a world where we are doing amazing things with holograms and telepresence and creating ways that I feel like I'm spending time with you, but digitally, why does flying to a city in Europe help lubricate the mechanism of trade?
I mean, we're doing this interview in person, not over Zoom. There is something incredibly special about human connection and the way that relationships are built that does not happen in a digital world, at least not yet. And I have a feeling for the foreseeable future. Maybe when we're all avatars, we'll see. But I think we learned this through the pandemic when the whole world went virtual. Most of humanity really felt that something was missing. And if you're able to take an asymmetric advantage to a business deal where your competitors are all interfacing with your potential customer over Zoom and you're there in person with them, who do you think has a better chance of winning the deal? It's you. Face-to-face for humans is not something going away anytime soon. It's only going to become more and more valuable as more digital technologies come about.
Give us a quick snapshot of what will we see you guys run after in the next, say, 3 years?
Sure. So we've kind of set a target for ourselves of it's a little mantra of 1 airplane per year. So that's the pace of iteration that we think is necessary to solve the technical challenges that we have ahead and deliver high-speed aircraft to our customers. So that's the next 3 for us.
In flying these unmanned aircraft, is this like you on like Microsoft Flight Sim? Like who flies it? Is it you?
Oh, absolutely not. No, we have a group of really, really skilled and experienced test pilots who have flown a wide range of different aircraft, crewed, uncrewed, that operate our aircraft while they're on the ground and when they're in the air. As we build up the software and autonomy stacks, we don't want the autonomy to kind of be in the way of getting the flight test data that we need. So we've kind of built a dual string of remote pilot and then build up the autonomy stack as it's ready. And nothing better to help advance and accelerate the autonomy stack than actual flight data to support it. So yeah, we've got a really awesome batch of flight test pilots who make sure that the aircraft does what it's supposed to do.
If I were the CEO, I would insist that I would get to fly it. And that's why I'm not the CEO. I do love this image and we'd love to see a photo of it at some point of the flag in your facility dedicated to the test pilots who died. Your sacrifice for now, it is not your life, but you're clearly sacrificing a lot that falls on your wife and your kids, your other co-founders. And so just want to say thank you. You guys are making big sacrifices to build something really important for this country and could shape our businesses, our lives, and certainly our nation in amazing ways. And so it's an amazing story to hear and really proud of all you built and can't wait to be an early passenger. So congrats on that and appreciate you being here.
Awesome.